Alright, in this video I want to talk about how we can take a player, so this black circle is going to be our player, and it has a center of px, py. Okay, how do I move this player so that it goes at a constant speed towards the mouse? Alright, so I don't want to just draw the player where the mouse is. I want the player to move towards the mouse. So in this case I decided to have a speed of 5. So I'm going to move 5 pixels towards the mouse. And then I'm going to move another 5 pixels towards the mouse. And then I'm going to move another 5 pixels towards the mouse. Okay, and of course if you wanted to slow this down, you would move 2 pixels. Right, have a speed of 2 or a speed of 8 to go faster. Alright, but the idea is that you're moving at a uniform speed, right? You're always moving the same distance towards the mouse. And to do that, right, to move our player, we need to calculate how far do I need to move horizontally and how far do I need to move vertically, which is going to be dx or delta x and delta y. Okay, so if I can figure out what dx and dy are, I just take my player x and add dx, take my player y and add dy, and I get to my new point, which is 5 pixels in the direction of the mouse. Okay, so the key here is determining what is dx and dy. And dx and dy are going to change depending on the location of the mouse. And I made a little program that should help us see that. So imagine this red line is our 5 pixels, and the horizontal blue line is our dx, and the vertical blue line is our dy. And you'll see here, right, if the mouse is over here, my dx is approximately 4, and my dy will be negative 2.7. But as I move the mouse, right, now my dx gets smaller, and my dy gets larger. If I move the mouse here, my dx gets larger and my dy gets smaller. And then of course in different quadrants you're going to have different signs, positive, positive. Here dy is negative, so we move upwards. Here dy is positive, so we move downwards. Here dx is negative, so we move left, right? But the main idea here is that I want to move this constant speed towards the mouse, so I have to calculate what dx and dy are going to get me to move 5 pixels or whatever speed you want towards the mouse, right? So you notice if I go straight vertical here, 0, negative 5, right? I'm going to move negative 5 pixels straight up. But here I need to move 3.6 and 3.4 horizontally and vertically. Okay, hopefully that makes sense. So our next step now is we know that we need to figure out dx and dy based on the position of the mouse. How do I calculate that? Okay. So a key idea here, let's choose green, a green line, not too thick. Okay, whoa, drawing lines all over the place. Okay, what I'd like to do is, hopefully I don't have to redo that. Oh, I do, it's all right. Okay, so color, green, thickness, this. Okay, so we've got this little triangle here, right? I want to move 5 pixels. I've got dx and dy, but I can't solve for dx and dy with just this information. So we're going to draw another triangle from the center of the player, well, kind of the center, to the mouse, and then we'll draw a 90-degree triangle here with a run and a rise, like so. Okay, so this triangle is going to help us because I can solve this triangle. I have I copied some stuff here. We'll get it still there. Oh, whoops, hold on. Undo, paste, select it all, and I want to move it up here. Okay, so we've got this little triangle here. The hypotenuse is 5. We've got dx and dy, and then we've got this green triangle here, where the horizontal distance is basically I'm going to call it the run. It's the distance between the center of the player and the x coordinate of the center and the x coordinate of the mouse. Right? If you subtract mx minus px, you'd get the run. This is the rise, the difference between the y value of the mouse and the y value of the player is the rise. And once you have the run and the rise, you can use Pythagoras' theorem to calculate the distance. So we know all 3 sides of this triangle. And that's really helpful, or we can calculate all 3 sides of this triangle. And that's really helpful because the small triangle and the big triangle are similar triangles, right? They have the same angles, okay? So the ratios of the sides should equal each other. So if I can try to draw this is always hard, but I'll try. Drawing with my mouse. Okay, so if I can draw this out, we can set up an equation where the ratio of this side to the hypotenuse, dx to the hypotenuse. So dx over 5 is equal to the ratio of this side to this side, right? This side to this side is equal to the ratio of this side to this side. So that's a little run over d. Run over d. I can calculate what d is. I can calculate what run is. I know what 5 is, or whatever speed you want to do. So this should help me be able to solve now. I can solve this equation to figure out what dx is. Yay! And once I know what dx is, I know that I'm going to move my player by dx, so it'll move horizontally that distance. And in the same way, we can take the ratio of this side to this side, right? The ratio of dy, that's a y, trust me, dy over 5, right? So dy over 5 will equal rise over d, right? This side to this side, this side to this side. It's the same ratio. So rise over d like so. And again, we can solve this equation for dy, right? Just multiply both sides by 5, and you can solve for dy. Okay, and once you have dy, you're going to say, hey, move the x coordinate of my player by dx, move the y coordinate of my player by dy, and now I'm in my new location. All right, that should do it. This should help you. You should be able to get this working now. You'll just have to do this calculation all the time, right? Because the mouse is going to be moving around. So basically, I'd recommend, well, you can either do it when the mouse moves, or you could do it like probably just every frame. Every frame, just recalculate dx, dy, and then move your player by whatever that dx, dy is. And of course, your dx and dy are going to change as the mouse moves. So your player will move towards the mouse, and then it will move to here, and it should follow it. Okay, hopefully that made sense, and you can get this working. Ask me for help if you need more clarification, but have fun with that.